Hi, welcome back to Meteorology 101. Streaming live. We're gonna go through a list of warnings. We got tornado warnings, about 6 of them going on right now, and from Texas, Oklahoma, Illinois. So you're two in Texas, three in Oklahoma, one in Illinois, one in Pennsylvania, and one in Maryland. So, and then we also have probably another 10 or 15 severe thunderstorm warnings. We'll touch some of those if we can, but right now we're going to just start on the list. We're going to go to Ellis, Hill, and Johnson counties, Texas, and look at these warnings. We got two warnings right on top of each other. We are in just near Dallas Fort Worth, Texas right now. So let's go ahead and look at these things, and we'll see. Got some pretty good stuff hanging down here. Pretty good line of thunderstorms and moving through. So see a lot of rotation right in that area. That's out of the warning area. So this one we actually have a area. You can definitely see some rotation through there. And let's do a cross section on that real quick and see how we shoot up into the upper levels. So you can see this the high reflectivities with the tilt of the storm going all the way up to 30,000 feet. So if there isn't a tornado on the ground, I'd be surprised on that one. So we are got that tilt, and we have looks like the vortex. We got that pretty strong updraft right there. So let's go back and actually let's do a base velocity real quick, and then we can probably see a little bit better rotation there on the cross section. A lot of rotation on the surface, a lot in the upper levels, not so much in the mid levels, but we are in a low elevation of the radar. So we could go to, we got a 1-inch hail, and that's right there in the wide open. But if we go into the upper tilt of the radar, now you can see as the high reflectivity start to move with that overhang, that storm starts to hang over this area, but all the heavy stuff's on the surface. So southwest quadrant of that thunderstorm is where that tornado will hit the ground. So as it comes up into that storm, now you have all this blow off and then higher reflectivity. So we go all the way up to the highest tilt of the radars, and now you can see where the heaviest reflectivity is, a little bit to the north of where that hail was. But here most of our reflectivity stay pretty steady right over that area where the 1-inch hail. That's 1.1 inch hail indicated by radar, and that goes all the way down to the surface. So then it becomes an open area. So we do have the updraft tilt coming up, and then pushing all that rain up above the freezing level. It freezes and then collides, coalesces, becomes bigger hailstones. The stronger the updraft, the bigger the hailstones. They can't fall through that updraft, and then once they do grow heavy enough, then they can fall. So this is falling down as 1-inch hail. So do a 3D scan on this thing real quick, and now we can definitely got some rotation all the way down, looks like to the surface on this thing. So you can see the tilt of that storm and the rotation all through the upper levels. So we can pull a base velocity at this level and see what we got here. Sometimes it gets a little hard to see, but this looks more like a horizontal rotation. But if you look at that dropping down into that the western part of that storm, you can definitely see the rotation in the down to 20,000 feet and below, almost down into the mid levels of that storm. So definitely got a severe thunderstorm with a tornado warning. So here's the rotation all the way up to them upper levels, and that is all the way down to the surface. So we're pretty much all the way down there. Got that rotation, and should be seeing down to the southwest quadrant of that storm. So rotation all the way into the upper levels. Pretty severe storm, pretty strong updraft, and bringing 1-inch hail. So that's that for that storm. And then we got the other cell to the north. We can pull that one up real quick, and did see some hail there. We got it's like about 0.95 inches of hail. That's almost an inch there too. And then this cell shoots up pretty good too. So looks like a couple isolated cells kind of mixed together there. We might have a downdraft in the center there. So let's see what let's get a look at this thing where Let me find the rotation button here. Now we do have rotation all the way in the upper levels with this one too. A little more disorganized, but like I said, I think that's two cells together, so we're kind of a little hard to isolate that. We got that little hollow area in the middle. So let's go to let's get that 3D scan back up again. I want to see. We definitely got the tilt, definitely got the updraft, definitely got the rotation, and then that base velocity. So now you can see the base, that velocity all the way up to 30,000 feet. So with that tilt of that storm, we got a pretty good rotation. So we can go to base velocity right here on the lowest tilt of the radar, and you can see all kind of rotation throughout that whole cell. That justifies these tornado warnings. And then the 1-inch hail is also a that's at least a severe thunderstorm, and this is just indicated by radar. I don't see any anything by any spotters just yet pop up. So here we go. Let's get these. Here's one tornado storm chaser on the ground. Got a tornado just west of Bloom, and 3-inch hail. What's this thing indicating here? We got 3-inch hail indicated and 1.5-inch hail indicated. That's a storm chaser, and that one is reporting from M-Ping Teacup 3-inch hail. So I'm not sure what that is, but probably a little exaggerated on that one, since there's a 1.5 inches right here, and then everything else has been an inch. So if we back this up, guess what we have. Let me recenter this a little bit better, and then back this thing up. Try to get that to that cell if we can, and then we can see if these tornadoes are on the ground. So now we got, let's see, a little bit of better rotation there. Let's see where we got. Then we got a area sticking out right here, so we got rotation, and this is the we got a vortex here. So let's go do a volume scan on that area. Alright, that just disappeared on me. Let me go back and do that again. Alright, so now we got some pretty strong reflectivities to the upper levels, and then this one is coming down to a vortex looking close to the surface. And I pull up the rotation on that one. We have to do another 3D scan on this to just show the reflectivities at the different levels. Let me zoom out a little bit there. So we definitely got rotation all the way up. You can see, looks like the board that was a spotted tornado on the ground at this time. This was back trying to find my time, 18Z. That's about 1 o'clock or so. See, 18Z, that's pretty far back. I'm not sure if that's right. Let's go back to 5418, 001851Z. So I was looking at 18Z, so that's 0Z. So about 7 o'clock, a couple hours ago. So we push this forward. Do another scan on this thing, and you can definitely see this one here also. Definitely got that rotation. I mean, if you're in a tornado on the ground, there's definitely a funnel cloud. So now we can show the lower reflectivities. You can see there's overshooting tops well above 50,000 feet. I mean, we're up to above 55,000 feet. I think it's about as high as this radar goes. And then we can pull this down to our higher reflectivities and get to the core of this thing. And you can see that vortex right there, pretty much right through there. As we get into the higher reflectivities, and then we get up to 50 dBz, that's the That's a significant part of this thing. And then you get into that purple, which we got very little there, but higher reflectivities like that would be mostly hail. So right now we're just looking at the rotation and the updraft. So let's see if we got something here. And there's our rotation all throughout the storm. And let's go to the latest shot. Still got these warnings out here. We got a pretty good rotation right through here. Let's go look at base velocity so we can see that rotation all throughout that storm. Let's go at 1.46 inch hail. We got echo tops all the way up to where we at here, about 47,000 feet. Do a cross section. Let's just do a cross section right across this area. You can definitely see the tilt there. That's the updraft, tilt of the storm, higher reflectivities in the upper levels, and then the hail just pretty much comes up. The updraft holds it up until it gets too heavy, and then it falls out of the storm. So that's why you'll see like a hail indicator on the surface on that radar, and there's really no indication of precip in the lower elevations of that radar. So we're all the way in the lower elevations right now. See, like, let me get rid of this real quick. So where that hail is right there, it's right in that middle area, and this is your updraft, and then the hail falls out in that area. So if we go in the upper angles of the radar, I'm going up and down there, but we go in the upper areas, you can see the higher reflectivities around that hail, and then that's an indication of hail because of the high reflectivities in the upper levels too. So, and then we can go up above that, and then there's nothing there again. So that's why you get that 1 inch hail dropping to the surface. Alright, so let's go back to our warnings window, and Oklahoma, Latimer County, Oklahoma. We'll shoot over there, download this loop. Center on that one. Get a lot of activity on these radar loops this time when there's storms like this going on. So the downloads sometimes take a little bit of time. Alright, there we go. So we're downloading the whole loop too, so we can watch this loop push through. And as it continues to download each frame, then we'll get a longer loop. Alright, so let's pause that. Do a cross section on this real quick and see what kind of tilt we have here. Pretty much that's vertical. High reflectivity is pretty far up, so we are in the severe criteria. And then radar indicated rotation is what we're typically looking for the warning to be set. So if you look at this one, here's our radar, and then down here we have the winds going out from the radar is all that red, and then the winds coming into the radar is the green. So we definitely have that rotation in that area. So that's why we have radar indicated rotation telling us there is a tornado. So they throw out a tornado warning for that reason. So if we do a 3D scan on this, let's go pull up the whole warning area. Now we're on the reflectivities again, so let's go drop that down. We can go to the lower reflectivities. We're well above 50,000 feet also on that, and then we come down into the core. So we're not as bad as we were on the other storm. We do have a little bit of a area starting over here. Maybe right there in the south. That's the southeast quadrant. So southwest quadrant. Maybe a little tail right there. Maybe being a funnel cloud. If we look at the rotation on this thing, we got pretty much horizontal rotation through that storm. So we're not quite there yet on the tornado. A little bit of rotation. Looking for I guess we're looking for more vertical rotation. So we do have some over on this end of it, the northwest part of the storm. Some vertical rotation going pretty far up into that upper levels too. So definitely got the rotation to justify that warning. You know, not undermining the warning by no means. Alright, there's our base reflectivity, and then we can light this up for a 3D scan and see what we got. It's all pretty much high reflectivity. It's all the way through that thing. So we do have the updraft. We got the rotation. I'm not seeing anything like, I mean, it's pretty significant. Don't get me wrong. I'm just not seeing like the structure of a massive tornado here. So let's go back. Pull a smaller scan on this thing. Sometimes it gets cluttered. Get this thing going here. Pull it right around that hail. So yeah, we got some little bit of angle there. Let's pull the cross section again. And now we do have the tilt. I mean, we do have the area right down through here, so there could definitely be a tornado closer to ground or on the ground in that area. Alright, let's go to Baltimore, Maryland. Looks like that one's on the top of the list. That's the latest warning right now. A couple small warnings areas there. Download that loop. This is for Baltimore County, Maryland. And then the other one is Carroll County, Maryland. Alright, so we got a pretty significant cell here. So it looks like maybe this was the one that was just set. And that one is Baltimore County. So the this area is starting to move in. That cell's starting to move into the this warning area, and it's still in that warning area. So that one hasn't expired yet. So let's go do a cross section. Let's get down in this open areas where we can see some tilt on this storm. Nothing real major there. It is definitely severe. $50 dBz's up to was that about 13,500 feet. Then let's do a 3D scan on this thing, and we're pretty much, let's get the rotation. Pretty much all horizontal rotation on that storm too. So there's rotation in the storm, so it indicated by radar that justifies the warning with the tornado. Through the base velocity, you'll see some rotation right there. Right there's a rotation in that storm. So we go back down here. We got the radar to the southwest. You always got to know where your radar is. And then the hot colors, the red, oranges, pinks, you know, that would all be going away from the radar. And your cool colors, that green, pretty much just mostly, it's all the times the green, it's the cool color coming into the radar. So there's your rotation, counterclockwise rotation, indicated by radar, and that justifies a tornado warning. Alright, and I just close that out. So let's get this back up real quick. Alright, now go back to my warnings. Ellis, Texas. I'm not sure if we touched on that one. We got Coles County, Illinois. Yeah, Ellis and Johnson were both in one warning area. We got Carroll County, Maryland. We touched on that one. Lawrence, Pennsylvania. You can shoot over to that one. There we go. Newcastle area. If you're in that area, you're in a tornado warning right now. Let's get the loop downloaded. Alright, so now we just had another warning pop up for Pennsylvania, and that is Butler and Lawrence. So let's do a 3D scan on this whole thing, see what we got going on. That's severe, definitely. They're strictly going on rotation on that one, so let's pull that warning up. We got a severe thunderstorm capable of producing a tornado, was located near Newcastle, moving east at 20 miles per hour. Hazard tornado, and the source's radar indicated rotation. So they're not taking any chances this evening, tossing these warnings out. I mean, they are severe. They are capable of creating these tornadoes. That you got some pretty severe storms going on right now. So if you're in these areas, you need to take cover. You could still have high winds, hail, debris, and you definitely got rotation on this the base velocity. So, but we do a cross section across this thing and see what we got. Pretty good tilt. We're reaching that severe level where we're pushing 50 dBZs at 10,000 feet, so we're definitely severe. Got tilt, we have rotation, so everything justifies the warning. So don't ignore that. Take cover if you're in those areas. All right, let's go to, got a few couple of these tornado warnings expired. They don't usually last long. About the longest a tornado warning is going to last about a half hour or so. All right, one for Ellis, Texas, in Baltimore, Maryland. We got Johnson, Texas, severe thunderstorm. Fisher and Jones County, Texas, severe thunderstorm. Pretty much Oklahoma and Texas are covered in warnings, severe thunderstorm warnings, flash flood warnings. Alabama has a flash flood warning. So let's get the loop on. Let's go cross section on that. Let's do that again here. Let's get drag this over to the center. We got some higher reflectivities. 2.77 inch hail indicated by radar. Go right across that hail area, and you can see those high reflectivities in the upper levels. 30,000 feet. I mean, that when you get to those 60 plus dBZs, you're getting into that's definitely hail reflectivity because the hail reflects light. The radar actually a lot better, so it'll show those higher reflectivities at the upper levels. Alright, so let's look for some. That's a cross section. I can't really do the rotation on that. I have to do the 3D scan, so let's go over there, pull a 3D scan on this thing, and we're just covered all the way to the top of this thing. 50 dBZs all the way over 40,000 feet. I mean, let's get a bigger area and see if we can kind of narrow this down a little bit. Pretty clobbered. Let's go to, we can always drop these reflectivities too. There we go. Now go into the higher reflectivities. Now you can start seeing a little bit more of a tilt with those higher reflectivities, and then a real strong core right there, that hail core right in the center of this thing. If we cut that all the way off to the purple, then that's your hail right there. So let's pull